complete the messages. But let me have a look at the message queue. So I go to View, Message Queues, and we have a little bit of a font problem again, but let me see if I can fix that. So let's go here. Okay, so let's see if now we can see those fonts a little bit better. No, well, each of these white circles, when everything is working fine, that is when you're not using Windows, will show a nice little black number in the center which indicates what task this corresponds to. So each of the circles is a task. If you want to count them, you will find 16 here. This one that I'm circling with my pointer is task number 0. So this one, if you go clockwise, is number 1. The next one is number 2, etc. As I mentioned during the presentation, you have 3 different queues to show: send, receive, and unexpected. What I'm going to do is I'm going to cancel all the send and receive things, and I'm just going to see what messages I have in unexpected, which is all of them. So what this is telling you is that you pretty much have a deadlock. If I look at the send messages, so there are 2 send messages still pending, but all the other processes have already completed sending. So all the problem seems to be in the receives. And when I look at the receives, I can also see that the pattern seems to be correct. So in other words, every process seems to try to receive from its neighbor. If you look at where the arrow is pointing, you don't see any process that is pointing in the opposite direction. So everything seems to be moving counterclockwise, which is what should happen. So if I go back to the source code, the information I just obtained is that there's a problem with the communication, but it looks like I'm sending and receiving from the correct direction, which means that rank left, rank right are probably okay. The only other thing that could be producing a deadlock is if I have my tags wrong. Because I have 2 sends, 2 receives, so I have 2 tags to identify the messages. Let's see. I have a I send towards the left with tag 1. That should translate into a receive from the right with tag 1 too. And what I see here is that when I receive from the right, which is line 71, I have tag 2, not tag 1. So this is what is happening. I'm not able to complete these messages because they're being sent in the correct direction. They're expected, but they arrive with the wrong tag. So MPI cannot complete the whole thing. And what I can do is I can get out of here and cross my fingers and nothing happens now. And I can edit the code, bcell MPI bug.c, so that I switch those tasks. So what I'm going to do is I'm going to swap those tags number 1 and 2 in the receive statements. And I think once we set this, we should be able to go through that whole section of the code and probably complete it successfully. I mean, at least it will run. That's not to say that it will give the right answer. But at least you can see that DDT is giving you the right tools to deal with these kind of problems. It's making it fairly easy for me to identify what all these bugs are coming from, and I actually need to know very little about the code that I'm debugging, other than, in very general terms, what the code does, and then knowing a little bit how to interpret the different function calls in NPI. So I'm going to submit with the same parameters as before, because essentially nothing has changed. That's fine. I think we're in business. So as I was saying, you can see that you have most of the tools that you might need to debug this type of code. Of course, this is a pretty small example, but there are a lot of good bugs crammed into this little example that I should thank Leyan for, because it's essentially the same thing he's used for the Total View course, and I have unashamedly used it here too. Okay. So we are already running. Well, we're not running, we're up. And I am not going to bother setting any breakpoints or anything. I'm just going to tell it to run. And the only thing I'm hoping is that we go through that whole communication section and see if I have any. Well, actually, I'm going to put a breakpoint just at the end, just in case I need to look at something else. So I'm going to put a breakpoint right at the very end. And just let it run. So let me look at the standard out. So if I look at the standard out just before I exit the code, now I have process 0 tells me maximum is 8, but the average is 0. In other words, now I have completed successfully all the MPI communications. There's been no crash, there's been nothing strange, but the output is still not correct. Now the maximum is correct, and I have gone through that communication correctly, so most likely the problem lies in these two MPI reduce statements that I have at the end, and of these two I only use the first one to get the average value, which is obtained by summing over all the elements in the array and then divided by the total number. What you can see is that both of them are MPI integers. One of them is a sum, one of them is a maximum. That seems fine. Both of them are reduced to the root processor 0, and both of them use MPI convol. So there's very little that can go wrong in a statement like this. The only thing I can really think of is that I have a wrong type. So either this sum is not an integer, or that's pretty much it, or is defined not as an scalar but an array, and therefore this redirection that I see in the code is erroneous. So if you go to the actual declaration of the variables, you will see the sum is declared as a double. So because MPI was expecting an integer, it's only going to have captured part of the value. So essentially it has rubbish by the time it gets to this operation where it calculates the average. What I need to do is I need to change this MPI int in the MPI reduce statement to an MPI double, and that will fix the problem. So I have pretty much run out of time, so I'm not going to do this again, but what I would do now is I would get out of DDT again. I would put an MPI double type in that MPI reduce statement, compile again, run it, and if you do it this time, you should get exactly the same values as you got for the sequential execution. So what I would encourage you to do is to run this example, or if you have some code that you want to develop, to debug, and you haven't had the chance to do it yet, you could use it as your own example, put it in your training account for these next couple of days, and play around with DDT, see if you can get used to the interface and so on. Before I finish, I would just like to remind you that you have my contact in those slides, so please feel free to send me an email if you're trying any of the examples and you run into trouble, or if there's some part of the debugging that you would like to do but you don't quite understand how to get to it. You should feel free to write to me. I'm not particularly fast replying, but I do reply. So that's always an option for you. And other than that, thank you very much for holding on so long. And I guess I will just take any final questions if there's anything before I finish. No? Okay, then thank you very much.
Nothing at NCSA. Thank you very much, Carlos. Any other sites?
Can you show quickly where you specified the 16 processors?
Would I specify the 16 processors?
Yeah, when
yes.
you call the DDT.
Just give me a second. So at the very beginning, when you get the welcome screen,
okay,
you click run
remember
debug,
now. Okay.
and then you can see on the bottom left there number of processes,
okay.
number of threads. Yep.
Okay. Is it possible to edit the code on the fly?
On the fly while you're running? No, I don't think so.
Okay.
At least if you can, I don't know of a way to do it.
Okay, thanks.
Any other questions? Okay, thank you, Carlos. Appreciate your time and sharing this with everyone. With that, we'll end for today and see you tomorrow morning. And thanks to Dean as well for his help there, Carlos.